Have you ever pondered what makes up the world around you? Not trees, cars, and buildings, but the minuscule building blocks that comprise everything we touch, see, and feel? Welcome to the fascinating journey of the discovery of electrons. Our story begins in the late 19th century, a time when the scientific world buzzed with the excitement of new discoveries. During this era, a British scientist named Sir William Crookes was conducting experiments with a fascinating phenomenon known as cathode rays. Crookes had created an apparatus, a glass tube with metal electrodes at each end. He removed almost all the air from the tube, creating what we call a vacuum. He then applied a high voltage between the electrodes. As electricity passed through, a stream of light traveled from the negative electrode, the cathode, to the positive electrode, the anode. These were the cathode rays. But what were these rays? A question that intrigued the scientific community. Crookes proposed that these rays were streams of particles, much smaller than atoms, and carried a negative charge. He was on the brink of a revolutionary discovery. Now enter another brilliant mind, J.J. Thomson. He took Crookes's cathode ray tube and placed it in a magnetic field. He observed that the path of the cathode rays bent in response to the magnetic field. This was a clear indication that the rays were indeed made up of particles with a negative charge. Thomson had discovered the electron, a subatomic particle smaller than an atom and carrying a negative charge. But Thomson didn't stop there. He conducted further experiments to determine the ratio of the charge of the electron to its mass. His findings showed that all electrons, no matter what type of atom they come from, have the same charge-to-mass ratio. This was a groundbreaking revelation, and it laid the foundation for the development of atomic theory and quantum mechanics. So, let's summarize. The discovery of electrons started with the curiosity of scientists like Crookes about the mysterious cathode rays. These rays, emitted in a vacuum tube under high voltage, were found to consist of negatively charged particles, later named electrons by Thomson. The realization that these particles were smaller than atoms and carried a negative charge revolutionized our understanding of the atomic world. The discovery of electrons and the exploration of cathode rays have shaped our understanding of the world. They have led to advancements in numerous fields, from physics and chemistry to electronics and computer science. So next time you switch on your computer, spare a thought for the tiny electrons whizzing around in the complex dance that powers our modern world. In the grand scheme of things, it's a reminder that even the smallest particles can have the most profound impacts. And isn't that a fascinating thought?